Math 1108, Section 8.8, Introduction to Complex Numbers. We already know that the square root of a negative real number is not a real number, but it is a number. It's called a non-real complex number. Each non-real complex number can be written so that the square root of -1 appears in its construction. Here is our definition. The imaginary unit is I equal to the square root of -1. If you square both sides of this equation, it follows that I to the second equals -1. The foregoing definition was probably done for convenience. Rather than writing the square root of -1, it is much simpler to write I in its place. Well, we will simplify the following square roots of negative numbers. The square root of -4, we're just going to apply the product property of roots. And we're going to think of the square root of -4 as the square root of -1 times the square root of 4. We're going to replace the square root of -1 with I, and the square root of 4 equals 2. So we'll just write this as 2 times I. So that is, the square root of -4 simplifies to 2I, where I is the square root of -1. The square root of -9, well, that's equivalent to the square root of -1 times the square root of 9. We're going to replace the square root of -1 with I, and the square root of 9 is 3, and we'll just write this as 3 times I. That's considered the simplified form. So by now you no doubt know the pattern. For this one, the square root of -16, this is the square root of -1 times the square root of 16. The square root of -1, we will replace that with the letter I for convenience, and the square root of 16 is 4, so this is just 4 times I. And then the square root of -25. That's the square root of -1 times the square root of 25. The square root of -1, we're going to replace that with I. The square root of 25 is 5, so we will write this as 5 times I. Okay, the next row, these are a little more complicated. In these 4 square roots, none of the radicands are perfect squares. So let's do it in parts. The square root of -8, we'll write it as the square root of -1 times the square root of 8. We will replace the square root of -1 with I. But we can still simplify the square root of 8. The largest factor of 8 that's a perfect square is 4, and 4 times 2 is 8. Okay, so let's write this as I times the square root of 4 times the square root of 2. The square root of 4 simplifies to 2, so we're going to have I times 2 times the square root of 2. One way to write this is the square root of 4 is 2, so if we put that on the left, and then the factor I, and then the square root of 2. Okay, the next one, the square root of -27. First, let's write it as the square root of -1 times the square root of 27. 27 is not a perfect square, but we can simplify the square root of 27. The largest factor of 27 that's a perfect square is 9. 9 times 3 is 27. So in this next step, we will replace the square root of negative 1 with I, and then the square root of 27 is equivalent to the square root of 9 times the square root of 3, because 9 times 3 is 27. And then the square root of 9 is 3, so we can write this as 3 times I times the square root of 3. Okay, the next one, the square root of negative 80. First, let's write it as the square root of negative 1 times the square root of 80. As before, we will replace the square root of negative 1 with I. 80 is not a perfect square. The largest factor of 80 that is a perfect square is 16, and 16 times 5 is 80. So in the next step, we'll replace the square root of negative 1 with I, and we'll replace the square root of 80 with the square root of 16 times the square root of 5, because 16 times 5 is 80. And then in the next step, the square root of 16 is 4, so we can write this as 4 times I times the square root of 5 for the simplified result. The next one in this row, the square root of negative 175, we'll write it as the square root of negative 1 times the square root of 175. 175 is not a perfect square. The largest factor of 175 that is a perfect square is 25. 25 times 7 is 175. In the next step, we replace the square root of negative 1 with I, and then we replace the square root of 175 with the square root of 25 times the square root of 7. The square root of 25 is 5, so we can write this as 5 times I times the square root of 7. Okay, and the next three, a couple of these numbers are a little bigger. The square root of negative 112, we'll start by writing it as the square root of negative 1 times the square root of 112. And we're going to replace the square root of negative 1 with I. And then the largest factor of 112 that is a perfect square is 16. 16 times 7 is 112. So we're going to replace the square root of 112 with the square root of 16 times the square root of 7. And the square root of 16 is 4, so this is replaced with 4 times I times the square root of 7. The next one, the square root of negative 500, let's write it to start with as the square root of negative 1 times the square root of 500. Replace the square root of negative 1 with I. And the largest factor of 500 that's a perfect square is 100. 100 times 5 is 500. So we'll replace the square root of 500 with the square root of 100 times the square root of 5. And then finally, the square root of 100 is 10, so we can write this as 10 times I times the square root of 5. Finally, the square root of negative 99, first write it as the square root of negative 1 times the square root of 99. The square root of 1, we replace square root of negative 1, we replace with I. The largest factor of 99 that's a perfect square is 9. 9 times 11 is 99. So we will replace the square root of 99 with the square root of 9 times the square root of 11. And the square root of 9 is 3. So this simplifies to 3 times I times the square root of 11. So those are pretty simple. Just factor out square root of negative 1, then simplify the square root of a positive number and replace the square root of -1 with I. Okay, a little bit more information about complex numbers. A complex number can be written in the form a plus b times I, where a and b are real numbers, and I is the square root of -1. The real part of a plus bi is the real number a, and the imaginary part of a plus bi is the real number b. So the imaginary part is the coefficient of I. It's the number that you multiply by I. Every real number is a complex number whose imaginary part is 0. For example, the real number 7 can be written in the form 7 plus 0 times I, where I is the square root of -1. But 0 times I is just 0, and so 7 plus 0 times I is 7. Since every real number, a, can be written in the form a plus 0 times I, it follows that the set of real numbers is a proper subset of the set of complex numbers. One more example of a complex number, something like, say, 5 minus 7i. Okay, that is a non-real complex number. 5 is the real part, and -7 is the imaginary part, and I is the square root of -1.